name is Evelyn, and today I'm going to talk about the topics of Model 1, which is tools for the study of physics. I'm going to be explaining a little bit about the 5 topics of this model and briefly explaining a little bit so that we can understand it better. So in topic 1, first we are going to talk about the history of physics, which for that we have to know what is physics, and physics is the science that researchers the fundamental concept of matter, energy, and space, and the relationships among them. This physics is the most basic of the sciences also. So next, we're going to talk about the chronology of the development of physics. So here we can see a lot of important characters that will intervene on the chronology of the development of physics, and we're going to talk about them. So Aristotle tried to establish the general principles that rule the behavior of natural bodies, applying concepts like motion, change of place, change of size or number, etc. Archimedes is considered one of the greatest mathematicians of the ancient times. He was one of the first to apply math to physical phenomena. Next, we have Galileo Galilei is considered as the father of modern physics. His experiments and studies of the motion of bodies were very important for the classical mechanics from now. Next, we have Isaac Newton that made a lot of contributions. He established the motion of laws that now they have his last name, as we all know, and also the universal gravitation principles. He also contributed to the development of calculus. Next, we have James Clerk. He formulated the electromagnetic theory that unifies the concepts of electricity and magnetism known to that time. Then we have Albert Einstein, who is very popular and we all know. He developed the theory of relativity, discovered the photoelectric effect, and did contributions to the quantum theory. Next, we have the scalar and vector quantities in topic 3. First, the scalar quantity can be described completely by its magnitude, that is a number and a unit. Vector quantities are a little bit different. It's completely specified by magnitude and direction. It consists in a number, unit, and a direction. A vector is a graphical representation of a vector quantity. It is represented by an arrow where its length points out the magnitude and the tip shows the direction. So right here, as you can see in the example, the problem says f equals 5n to east. The scale we're going to use is 1n equals 1 centimeter. So this, it has to measure 5 centimeters because 1n equals 1 centimeter and they're asking for 5. So right here we have 5 centimeters, right? Then as you can see, it's pointing to the east because right here you can see they are asking for it to point to the east. So right here you can see as a vector, the arrow, the length points out the magnitude. Here is the magnitude. And right here we can see also that the tip shows the direction. The direction is leading to east. Then on topic 4, we have operations with vectors. This is a little bit more complicated, but not that much. It is very easy to explain. First of all, we have the parallelogram method. It only works for 2 vectors. First, you draw with the proper scale that they will ask you, and both vectors will be coming from the same origin point. So as you can see here, this is a starting point, and here you see the 2 vectors are starting from the starting point. And for the result of the vector, we have to put a line right here and right here. And the point of this line to the starting point will be the result of the vector. Next, we have tiltative method. It works for 2 or more vectors. It consists on drawing with a proper scale, the scale that they ask you, one of the vectors, and then then where the first one ends at the tip of the arrow, we start drawing the second vector, and we continue in the same way until all the vectors we want to add are used. So as you can see here in the example, this is the starting point, and here is the first vector, and where the first vector ends, starts the second vector, and so on and so on. But the result comes from the last vector, which is this one, and the point of the last vector to the starting point, there is where you can see the result of the vector. So yeah, that's how you can see. So we apply this formula to find the magnitude of the resultant vector. Here it is. And we apply the formula to obtain the direction. So here it is. So this is going to give you more specific answers. So finally, in topic 5, we're going to see the descriptions of movement in one dimension. First, we're going to talk about speed. Speed is the travel distance per unit of time. It is a scalar quantity. And right here, you can see there's a formula. This formula is to see what speed is. So if a problem says to you to find the speed, this is the formula you would typically use. The velocity, which is this one, is the displacement per unit of time. It is a vector quantity, not like the other one. The other one was scalar. This is vector quantity. And this is the formula so that you can see the velocity. The acceleration is the rate of change of velocity per unit of time. This is a vector quantity, like the last one, this one. And this is the formula. Okay, so now we have the concept of the rate of change in velocity. This refers to how the displacement is changing regarding to time. For example, when a change occurs in a very short time, it is called instantaneous velocity. And here is, well, the formula for instantaneous velocity, which it refers to how the displacement of an object changes, but in a very small time. And it is mathematically expressed as this. And next, we have the acceleration as a rate of change. It refers to how the velocity is changing with respect to time. And it is mathematically expressed as this. This is the formula. So here we have an example of the topic 5, which says a woman runs 200 meters east, then she changes the direction and runs 300 meters west. If the whole trip takes 60 seconds, what are the average speed and the average velocity? So right here, we can first see the total distance, which is pretty simple. Right here it says 200 meters east first and then 300 meters west. So if you add these up, it gives you 500 meters. And then we use the formula for speed, which is right here, the formula for speed. We used it in this example. So right here you put 500 meters, the distance, and the time was 60 seconds. Right here it says you just divide this and it gives you 8.33 meters per second. I'm sorry. And this is your result. Next, I'm going to show you a little bit about another example, but it's vector addition. Here in the example, it says, what is the resultant vector done by a person? first walks 200 meters in the direction 30 degrees, then travels 90 meters north, then 100 meters west, and finally walks 50 meters at the angle of 37 degrees below the negative axis. So right here, you can put the information that the problem says to you. A equals 200 meters, 30 degrees. Right here, B equals 90 meters to north, and north is 90 degrees. Then 100 meters to west, and west is 180 degrees, and 50 meters at an angle, here is it catchy, at an angle of 34 below the negative axis. So right here, it gives us 145. And the scale I'm going to use is 25 meters equals 1 centimeter, right? So this problem, like other problems, you can resolve on your notebook, but I use a computer simulator vector addition. So right here, we can see the first, and that it's A. A is 200 meters, 30. This is the first one. The second one is this one, which is 90 meters, 90 degrees. And I did that so on until I did, well, the 4 of them. After that, as I told you on topic 4, the result of that is the endpoint of the last vector to the starting point. And this gave me 7.3 centimeters and 74.1 degrees. But I used a scale, so I put 7.3 multiplied by 25, it gave me 182 meters and 74.1 degrees. And that's how you do it. So that is it for my presentation. I hope you like it, and I hope I could be clear about all these topics and refresh a little bit all the topics that we saw in class. Thank you very much.